Hello everyone, my name is Alexander Leung, and I'm here together with Calvin Lee. The two of us will be presenting about nuclear power and submarine propulsion systems. We'll first start off with the history of nuclear energy and continue on with nuclear fission. We'll go into the economics of nuclear power and show how a nuclear reactor actually works. We'll then end off with the advantages and disadvantages of nuclear power and also how nuclear waste is currently managed.
I will then define what a submarine is and briefly describe the history of submarine propulsion, continuing with the start of nuclear submarines and how they work, and explaining nuclear powered propulsion systems, and ending off with the advantages and disadvantages of nuclear submarines.
Nuclear power in Canada actually started in 1945 with the zero-energy experimental power reactor. It sustained the first nuclear reaction which created 1 watt of nuclear power. In 1952, the Atomic Energy of Canada was formed, which mandates research and develops peaceful applications of nuclear power. In 2011 today, we have 18 reactors in 3 provinces and actually sustains 15% of Canada's electricity. There are 2 types of nuclear reaction, fission and fusion. Since fission is the only type of controlled nuclear reaction today, we use nuclear fission to produce steam to drive turbines, which then creates electricity. Nuclear power currently provides around 14% of the world's electricity and is mainly developed in US, France, and Japan. Nuclear fission is all about splitting of an atom to release energy. We commonly use uranium-235, which is an isotope of uranium-238. The splitting of the atom expels energy and also expels neutrons, which is able to sustain nuclear fission. Here we have a diagram of nuclear fission. In the red circle we have a uranium atom which absorbs a neutron. When it absorbs the neutron, nuclear fission occurs and the uranium atom splits into 2 byproducts. This also releases several other neutrons, which then continue on with the fission process. There are 4 main drivers of nuclear power costs. First of which is the nuclear fuel, which accounts for 50% of all nuclear power costs. The uranium needs to be refined, enriched, and fabricated before being used as nuclear fuel. Then we have the construction of a nuclear power plant, which ranges from $3 to $5 billion in total capital costs. Then we have the operating cost of a nuclear power plant, which accounts for 10% of the construction of the nuclear power plant. Lastly, we must include the managing of waste and decommissioning of the nuclear power plant in our total cost of nuclear power. Looking at this graph, we can see the electricity production costs between 1995 and 2008 for 4 different types of energy sources. Just by looking at this graph itself, we can see that nuclear power is hovering in a linear line above 2 cents per kilowatt hour, whereas oil is in a rapid increase, going way above 18 cents per kilowatt hour. Nuclear reactors are really similar to fossil fuel and coal plants. We insert uranium rods into nuclear reactors, and heat is expelled from the reactor. The heat is used to heat up the water, and steam is then produced via the heat of the reaction. Steam turbines then use the steam to generate electricity and is then distributed around the world. Here we have a diagram depicting how a nuclear reactor actually works. As we can see in number 1, we have nuclear fission occurring inside the nuclear reactor. At number 2, we have the heat transferred to the steam generator where steam forms and is then sent to the steam turbine where electricity is generated. The steam routes to the condenser, where the cool water removes excess heat and turns the steam into water. The water is then pumped back into the generator for reuse. There are many advantages to using nuclear power. First of all, it has very minimal CO2 emissions. Comparing to fossil fuel waste, nuclear waste is very small and often confined. Nuclear waste also decays over time and has no direct negative impact on the ecosystem when confined. It is very safe, reliable, and abundant. Now there are disadvantages to using nuclear power as well. There's an accumulation of waste and radiation from the waste nuclear fuel. The nuclear waste takes thousands of years to decay, and many accidents have actually happened with nuclear power plants around the world. Also, there are high capital costs when creating a nuclear reactor. We produce nuclear waste after the fission process. Waste fuel is stored on site in deep water pools that are 3 meters deep or in concrete structures that are 1 meter thick. This provides shielding and cooling for the waste fuel. For a long-term strategy, the waste fuel is then put into corrosion-resistant containers and then set out in concrete structures for a few thousand years.
So what is a submarine? A submarine is a vessel designed to operate below the surface of the water. Its primary purpose is for military use. However, they are also used for research and navigation purposes. Now I will talk to you about the history of submarine propulsion systems. This picture shows a timeline of submarine development which first started in the early 1600s. In 1776, the first military-use submarine, the Turtle, was built. The Turtle was propelled by hand-operated cranks, and its major offensive strategy was to attach explosive devices to the hulls of enemy warships. However, this was not very successful, because the Turtle was usually too slow to catch up to enemy ships, and attaching explosives through screw-type devices underwater was very difficult. In the early 1900s, the diesel-electric propulsion system was established. It uses a diesel engine to connect to an electrical generator that powers an electric motor. This motor drives the propeller shaft, which propels the submarine underwater. At the same time, the diesel generator charges a bank of storage batteries, which allows the submarine to go deeper and stay underwater for longer periods of time. However, in 1954, the development of nuclear submarines changed this technology significantly. The first nuclear submarine was developed in the United States in 1954. It was called the Nautilus. Just a few years after being put to sea, the Nautilus became the first submarine to sail beneath the Arctic ice and reaching North Pole on August 3, 1958. Being able to travel the globe undetected meant that enemy military and commercial ships were exposed to submarine attacks at any time and virtually at any place in the world. Over time, the submarines were armed with ballistic missiles and also with nuclear warheads. A nuclear submarine has an inner hull which protects the crew from the enormous water pressure, and an outer hull which shapes the submarine. The propeller is powered by the nuclear reactor and propels the submarine forward. The rudder can direct the submarine from left to right. Ballast and trim tanks are located in the front and rear of the submarine, and by taking in and releasing water, the altitude of the submarine can be controlled. The engine room contains main turbines to drive the propeller, air compressors, and power generators. The water and atmospheric control decontaminates the crew's breathing air, and can also purify seawater to be used for drinking. The maneuvering room is used to control all operating systems of the vessel, turbines, generators, and nuclear reactors. The nuclear reactor is located in the middle of the submarine. The crew space is a place where crew can eat, rest, and sleep. The sail contains all communication devices, radars, and periscopes. The control and attack center governs all weaponry usage and operation throughout the whole submarine. The sonar sphere located in the front of the submarine is able to detect all obstacles surrounding the submarine. The following is a nuclear power propulsion system. In a closed-loop fashion, water is pressurized and heated without boiling by the nuclear reactor on the left. It travels to the steam generator where steam is generated. The steam produced travels to the secondary circuit on the right and powers two major turbines. The first turbine propels the submarine, where the second turbine produces energy used to power all electrical components throughout the submarine. The steam used is then condensed and recycled and travels back to the steam generator to be reused. This process repeats. A major advantage of nuclear submarines is its independence, endurance, and long lifetime. In a single refueling, a nuclear submarine can stay underwater for years at a time. The only reason it would have to resurface again is if a crew member gets sick or when food supplies run out. However, there are disadvantages as well. If a nuclear submarine ever gets struck and sinks to the bottom of the ocean, radiation can possibly leak out to the surrounding environment and polluting all life form. Also, the cost of a nuclear submarine is phenomenal. On average, a nuclear submarine costs around $8 billion and can go all the way up to $14 billion. This concludes our presentation today. Thank you very much for listening.